Scientists have just uncovered something extraordinary about the universe. Recently received images from the James Webb telescope reveal an anomaly that suggests something strange existed even before the Big Bang. Renowned scientists around the globe are now cautioning that these discoveries could challenge and potentially overturn our current understanding of the universe.
Well, Einstein says the universe is a bubble. We live on the skin of the bubble, and the bubble's expanding. That's called the Big Bang theory. String theory says there are other bubbles out there. There's a bubble bath of universes, and universes are being formed all the time. Big bangs are happening even as we speak. So we have this bubble bath of universes. Right. So there was something before Genesis. There was something before the Big Bang. And we're going to detect gravity waves from the instant of creation with gravity wave detectors in outer space one day.
Our understanding of the universe's evolution after the Big Bang, how the first stars, galaxies, and black holes formed, is well established. However, a critical question remains. What existed before the Big Bang? Now, it appears that we have found an answer, though it has left scientists astounded. Findings from the Webb telescope indicate that something unusual might have existed before that event, suggesting potential gaps in our standard cosmological models. So, what exactly have we discovered, and how has it shocked astronomers worldwide? In the 1920s, when scientists first studied distant galaxies, they made a surprising discovery. Most galaxies appeared to be moving away from us. Initially, this led some to speculate that Earth might be at the universe's center. However, further observations revealed that while most galaxies are receding, some, like the Andromeda Galaxy, are moving toward us. This was puzzling at the time. After decades of detailed observations and research, scientists concluded that it's not the galaxies themselves moving through space. Rather, space itself is expanding. This expansion, however, is not straightforward. It has no central point. This means that wherever you stand in the universe, you will perceive everything as moving away from you, as if each point is the center of the universe. This realization led to the understanding that the universe has no fixed center. Everything is moving away from everything else due to this cosmic expansion. Moreover, scientists have observed that space is not only expanding but accelerating, which means that the farther a galaxy is, the faster it is moving away from us. Recent observations have confirmed that 97% of galaxies in the observable universe are receding from us faster than the speed of light. But how can this be, given that one of the fundamental laws of physics is that nothing can travel faster than light? The answer lies in Einstein's theory of special relativity. This theory states that nothing can move faster than light through space. However, as previously mentioned, distant galaxies aren't moving away from us through space. Instead, the space between us and them is expanding. This expansion of space causes the distance between us and these galaxies to increase faster than light could travel. In other words, it's not the galaxies themselves speeding away, but rather the space itself stretching. Therefore, they're not breaking any cosmic speed limits. They're simply being carried along by the universe's expansion. Scientists believe that this expansion began with the Big Bang itself. Before the Big Bang, there was no space, no time, and no matter as we know it. The Big Bang marks the birth of our universe and the beginning of time and space. When we talk about the Big Bang, we often envision it as the moment when the universe exploded into existence, expanding from a tiny, hot point into the vast space filled with stars and galaxies that we observe today. According to our standard cosmological model, about 14 billion years ago, our entire observable universe and everything beyond that we cannot see was compressed into a tiny, infinite point known as the singularity. You might think of this singularity as a single point in space, but that's not accurate. That would be true if the universe were finite, but if the universe is infinite, and evidence suggests it is, then it has always been infinite. So, the Big Bang did not occur at a particular point in space, rather it happened everywhere. This means that the first galaxies did not form in any specific region of space. They formed everywhere in the universe, even beyond the observable universe that we cannot see. It seems as though matter came into existence everywhere in the universe at a particular time. However, the Big Bang alone doesn't explain everything, such as why the universe looks the same in all directions, or why it appears so flat and spread out. If you take a telescope and look in different directions, it roughly looks the same. This is where the idea of inflation comes in. Inflation suggests that just before the Big Bang, the universe underwent a period of incredibly rapid expansion. In less than a trillionth of a second, it stretched from a tiny size to something much larger. This inflationary expansion was driven by a strange kind of energy that was present in empty space. But this empty space wasn't empty as we usually think. Instead, it was filled with special energy that pushed space to expand at an incredible speed. The universe expanded into some pre-existing container. Before this rapid expansion, the universe was extremely cold and nearly empty. There were no stars, galaxies, or even particles, just a cold, dark, empty void. However, this void wasn't truly empty because it contained this inflationary energy that stretched the universe out. During this expansion, any lumps or irregularities in space were smoothed out, making the universe appear flat and uniform on large scales today. Once inflation ended, all the energy stored in space was released. This sudden release of energy heated everything up and triggered what we now call the Big Bang, the hot, dense explosion that filled the universe with particles, light, and everything needed for galaxies, stars, and planets to eventually form. This idea of inflation not only explains why the universe looks the way it does, but also suggests that before the Big Bang, the universe was a cold, empty space that rapidly stretched out due to this strange energy. This expansion laid the foundation for everything that followed. However, while inflation answers some significant questions, it also raises new ones. For instance, what exactly caused this inflation to start and stop? And what was this mysterious energy that drove it? New discoveries are now revealing the existence of strange phenomena before the Big Bang. The James Webb Space Telescope recently made a startling discovery. It found that the universe is expanding at different rates in different directions. This is significant because, until now, scientists believed that the universe's expansion was uniform. The theory of cosmic inflation, which suggests that the universe expanded rapidly due to vacuum energy before the Big Bang, also supports the idea that this expansion should be uniform everywhere. However, if these new findings from the Webb telescope are accurate, they challenge our understanding of inflation and raise the question: why is the universe expanding at different rates in different regions? Is there something beyond dark energy influencing this uneven expansion? Dark energy is thought to be responsible for the accelerated expansion of the universe, but recent Webb telescope discoveries suggest that there might be more we don't yet understand. It could mean that some unknown force is influencing how space expands in different directions. Additionally, scientists using the Webb telescope have observed thousands of mysterious red dots in the deep field images it captured. Initially, they thought these might be distant galaxies, but they exhibit strange properties that don't align with what we expect from early galaxies based on current models. These objects behave in ways that challenge our understanding, hinting that there might be unknown types of objects that existed in the early universe. These findings are significant because they suggest that something existed before the Big Bang, and that something very strange might have happened before the universe we know came into being. Nobel-winning scientists and experts are now suggesting that our current understanding of the universe might be missing a crucial piece. The Standard Model of Cosmology explains the evolution of the universe from the Big Bang onward, but it doesn't fully address what came before. The new observations made by the Webb telescope hint that there could be more to the story, something that occurred in the cold, empty space that existed before the universe expanded. These discoveries also challenge the traditional inflation theory, which posits that a burst of rapid expansion driven by vacuum energy set the stage for the Big Bang. If the universe was truly shaped by this smooth, uniform inflation, why are we now seeing signs that the universe is expanding at different rates in different directions? It suggests that something more complex might have been occurring before the Big Bang, influencing the universe in ways we're only now beginning to understand. In addition to these expansion anomalies, the Webb telescope has detected strange objects in the early universe that don't fit into our existing models. These findings indicate that the early universe might have been more diverse and mysterious than previously thought. All of this evidence points to the possibility that the Big Bang wasn't the absolute beginning, but rather a transition from something else, something we still don't fully comprehend. As scientists continue to analyze these findings, they are increasingly open to the idea that our current theories might need significant revisions. The possibility that a pre-Big Bang era existed, where different forces or conditions shaped the universe, could revolutionize our understanding of cosmology.